Okay, let's start off with the paper 2, the solution of paper 2, in which we have again different type of problem, different sections. In first section we have 6 questions related with single option correct type. Let's start off with the first problem. It's related with matrices, where some matrix P is given and it's being told that higher power of this P as power 50 minus Q is a unit matrix. Clearly you have to look for the pattern as far as P power, higher power are concerned. Once you figure out the value of P square based on the value given, you will find that these elements are not going to change, but these elements you will have it as this. In case of P cube, you will find again these 6 elements are going to be the same, but these elements here in place of 8 you will have 12, and here in place of 16 plus 32 you will have 16 plus 32 plus 48. Clearly then inductively you can check the power of P as 50 is going to make that matrix as the multiples of 4, which is clearly going to be 200 here and here, and this is going to be related with the sum of natural numbers. If you take something common, you will get it as then 8 times n into n plus 1. You should be getting 16 times, but by 2 is going to take care of that 16. This is what is the value of P50 when n is 50. That is something which you have to compute. By this then you can observe the matrix Q, which turns out to be P to the power 50 minus I. All these elements are going to be 0, and this particular element is then going to be 200. This one is also going to be 200. This is what is a matrix Q you have. In the problem it is this expression which you need to simplify. Clearly you can check out of these two quantities 31, 32, we have 8 times 50, 51, and then we have 200, this as 200. Simplifying this expression, you would be getting the net sum as 103, which is clearly the option B of that one. My next problem is related to trigonometrical series, where we in general follow majority of the times the difference method. You have product of two sine given whose difference is a constant, so let's multiply and divide with that constant quantity, that is sine of 30 degree. And let me write that 30 degree as note that here AK stands for and this expression you can check is nothing else but sine 30, which I have taken care of by taking 2 here. If you simplify this whole matter, you can check this sigma is then simplifying to cot AK minus cot of AK plus 1, which is then further simplifying to cot of A1 minus cot of A14. Substituting the value of K as 1 and 14 in this and simplifying this matter, you should be getting this ultimate expression as this, which is matching with the option C. Please remember, there you have to utilize cot of 75 degree, cot 15, that is 2 minus root 3. In the next problem, it's related to progression. There are some conditions given that logs are in AP. Clearly then you can check if you remove all the logs, the numbers are going to form a GP. So B1, B2, B3 are in GP. Clearly then the common ratio of that GP is going to be 2, because common difference of AP was ln 2. Hence then the value of BK is like this. And since AIs are in AP, and further it is given to you that A1 and B1 are same, and A51 and B51 are also equal. Let's make them equal. Instead of B1 I am utilizing A1 here. This is then going to be 2 to the power 50. Then the common difference is known to you as A1. After this we have some series as T, in which you need to add all the BIs. The sum is then clearly going to be equal to this much. Here instead of B1 I can take A1. As it is given to you that A1 and B1 are equal, and it's being told that all the BIs are positive, so AI is positive, hence we can safely say this, that T is lesser than this quantity. Now let's move on to S, which is the sum of all the 51 terms of that AP. Into the capital T value, which is nothing else but this. Simplifying that expression, you should be getting this. Now if you look at the value of S here, which you have got, clearly I can say this, that this quantity is going to dominate over this expression, which is A1 into 2 to the power 51. The quantity with respect to which T was smaller than that, this S is greater than this. Clearly then I can claim this, that S is greater than T. Utilizing this particular ratio you can simplify this matter. And after this, in addition to this, then you have to compare A101 and B101 also. A101 is nothing else but this, into the capital D value, which is and B101 if you look at this expression, just by looking at these two quantities, if you compare them, you will find this, that A101 is lesser than B101. Clubbing these two informations together, you will find that it's the option B which is correct in that one. Next problem is related to this one, definite integral. This is one of the standard problem. I guess majority of you people have already dealt with this type of problem, where we relate it with this particular property. If you utilize this fact here for that function fx, you will find that it's free from the exponential part, which is clearly going to create problem while integrating that function. The net function which you are going to left is this. Since this is an even function, you can cancel this half and make it 0 to pi by 2, and then you have product of two function, use integration by parts, substitute the limits, and hence you will end up getting the final answer as this quantity, which is the option A. In the next problem, you are dealing with image of one point with respect to a plane. You can utilize one shortcut to manage its image. This is going to give you that point P, the image, as -153. Now you are looking at a plane which passes through this point P and containing some line, and line passes through origin, so I can then write equation of that plane as this, since this point lies on it. So I can write this statement, and the line given to you is lying in that plane, so the dot product of that line and this normal vector should be 0. Solving these two equations, you can check A, B, C are going to be related with one another. Once you simplify this whole matter, you will end up getting that equation as in this one, which is matching with the option C of that problem. The next problem is related to some area. Since we have to make sure that x is less than equal to 6, this is the right side boundary, and the other one is related to the straight line. We are looking at the area within this region, and within this region you have to consider two different parabolic inequalities. Like this, and the common region which you are interested in is this shaded part. In order to figure out this region, it's better if you figure out this area, and the area of this trapezium. You can then figure out these points. Once you solve those equations, you can manage these coordinates and figure out these areas by integration, and manage this area of trapezium, subtract the sum of these two quantities from that, we'll end up getting this shaded area. These shaded areas, you can verify it. This quantity is going to be 16 by 3 square unit, and this quantity is going to be 2 by 3 square unit, and the total trapezium area is going to be equal to 15 by 2. Subtracting the sum of these two quantities from this would give you option as 3 by 2, which is the option C in that problem. Next problem is related to the multiple option correct section. The first problem was related to parabola and circle. The center of that circle is given to you in that problem as 2, 8 with radius as 2. And you are looking at shortest distance. Obviously shortest distance you can measure it along a common normal. So let's write down equation of general normal to that parabola. And since this is normal to the circle, so clearly 2, 8 should lie on it. Once you substitute 2, 8 on this, you can check t turns out to be 2, so clearly that point P is 4, 4, hence you know the distance PS by point distance formula. Simply you can check that quantity turns out to be 2 root 5. Once you know this, you know the fact that QS is nothing else but the radius, which is 2. Hence you know clearly then what is the value of the distance PQ, which is 2 root 5 minus 2. Hence you can check the option B is not correct. The ratio is simplifying here too. Which is then root 5 plus 1 by 4 after simplifying it. It is given something else. So this is not a correct option. But option B was perfectly fine. In option C, you have to figure out intercept of the normal. The x-intercept. Clearly you have to make y0. If you make y0, t will get cancelled off and the value of x turns out to be 2 plus t square, which is 6. Clearly then this is also correct. And in the option D, you are looking at slope of tangent to that circle at Q. Since minus 2 is the slope of this normal, which is a common normal, clearly then the slope of common tangent would be negative reciprocal, which is matching with the option D. So the correct set of answers here are A, C, D. As far as next problem is concerned, we have U as a unit vector, W as a unit vector, but about vector V nothing is given and it's being told that that V vector satisfy these conditions. One thing you can notice here that, if I consider it in terms of magnitude and cos theta, you can check that cos of theta turns out to be 1 implies then theta is 0. Their magnitudes are already matching. This is also a unit vector, W is also a unit vector, their directions are matching. You can then safely claim this, that the W vector is nothing else but U cross V vector. And even though W is fixed, U is unknown, still you can have infinitely many options for V, because you can check I cross J is K, but I cross I plus J is also K. You can have so many options for the second vector to match this result. So out of the first two options, it's only B which is correct. A is clearly not correct. Now for C, it is given to you that U vector lies in XY plane. If U vector lies in XY plane, clearly its Z component should be 0. Then if I were to consider the VT, U cross V value, you can check this particular expression has to be equal to W. The coefficient of I cap here is U2 V3. Coefficient of J cap is U1 V3. And even if you discard the coefficient of K cap and if you equate the two components of I cap and J cap, since in W vector coefficient of I cap and J cap are matching, then these two quantities should match magnitude wise. You can then say that U1 magnitude has to match with magnitude of U2. So clearly then the option C is correct. The same thing is given in that problem. In a similar manner, option D you verify, since that is in XZ plane, you have to make U2 0 and proceed ahead with it. But you will find that the relationship what is given in that option D is not correct, because ultimately what you should end up getting is this. It's given other way around. That coefficient 2 was given here. So D is not correct. So the correct set of options here are B and C. Next problem is related with continuity and differentiability. but the way that function was given, you can check those moduli are actually meaningless. For cos, it's quite obvious that you can remove modulus, because for cos of minus x is cos x itself. So first term is straight away equivalent to this quantity. That modulus has no role to play. But in case of the second term, because of sign, the mod may change the value outside, but in the exterior part of it, you can check you have mod of x, which is going to take care of it. So the ultimate expression what is given is going to be free from modulus, which is a cos of x cube minus x and bx sine of x cube plus x. Clearly this function is continuous everywhere, is differentiable also everywhere. By this you can check that AB is immaterial. You can take AB anything, function is going to be continuously differentiable. The correct options are A and B for 45. In the 46th problem, you have to relate it with, first of all, definite integration as a limit of a sum after taking ln. If I were to take ln on both the side, you can check you have x by n outside, and then you have this is a kind of expression you have. If you take simply ln and adjust that n to the power n and n factorial, you can check they'll take care of one another once you convert them, that expression, as a function of r by n. Now if I have to relate this with integral, I should be getting here, you have limit and approaching infinity here. Once you have got this integral, you can check xt equal to t substitution, xt equal to z as a substitution is going to make this integral even simpler than this. In one of the option you can check you are dealing with f dash by f, that's why I am differentiating it. And if you differentiate this relation, f dash by f turns out to be ln of 1 plus x by 1 plus x square by Leibniz formula. If I were to make this quantity 0, one thing you can notice further before I proceed, since ln fx is this quantity, safely you can claim this, that since fx is e raised to the power this integral, clearly then fx is positive always. Once fx is positive always, I can say this, that if I were to deal with maxima minima here, I have to make only this numerator 0. And you can check this expression will be 0 when x is 1, as this quantity turns out to be ln 2 by 2. After 2, you can check this quantity is negative, and prior to 1, this is positive. So function is increasing first and then decreasing. From here itself, I can claim this, that f of half has to be lesser than f of 1, f of 1/3 has to be lesser than f of 2/3. You can write equality because we refer it as less than or equal to, but you cannot have equality perfectly. As far as these two options are concerned, you can check option A is not correct and option B is correct. As far as f dash 2 value is concerned, Since this quantity is a fraction, I can safely say this is going to be a negative quantity, so option C is also correct. And as far as the last option is concerned, f dash of 3 by f of 3 is ln of 2 by 5, and f dash of 2 by f2 is ln of 3 by 5. Clearly then you can check option D is not correct. Inequality sign should be other way around. D is not correct. The correct answers here are B and C for this particular problem. The next problem is related with limit. You can check the conditions which are given is going to make sure that you have 0 by 0 form. So I am going ahead with L hospital. Since this limit is given to you as 1, and if I substitute x as 2, the way those conditions are given, you can check from this itself, you will end up getting this result, that f of 2 and f double dash of 2 are equal. But if you observe the way codomain of f was defined, it is ranging in 0 to infinity, I can then safely claim this, that this quantity is a positive quantity, so f double dash 2 is also positive. And since f dash 2 was 0, clearly then x equal to 2 is one of the extrema. But since double derivative is positive, it is a point of local minima then. Since we have this information, so clearly option C is wrong, option B is wrong. And once you know this, I can say then in option D that equation must have one root, must have at least one root as 2. I can't claim anything else, they have a root or not, so option D is also correct. Overall, if you observe, A and D are the two correct answers for this problem. In the next one, it was a very much straightforward problem. If you consider z as x plus iy, since you are looking at its locus, if I take a plus ibt to the side of z, and if you equate real and real part, imaginary and imaginary part, and then if you eliminate t, because t is a parameter, you should end up getting equation as a circle depending on certain conditions which are given, maybe a line. So overall you can observe the correct answers are A, C and D for this particular problem. Okay, next problem was related with two straight lines. You are looking at infinite solution, unique solution or no solution. I am directly comparing the coefficients of x, y and the constant term. One thing you can check, if I make sure that all these ratios are same, clearly they'll correspond to infinitely many solutions because lines are constant. But if I make sure that slopes are same but intercepts are not same, the constant terms are not in proportion, then you can check they are precisely parallel, so you will have no solution. But if I make sure that they are not parallel, clearly then this case is going to correspond to unique solution. Simplifying all these relations, you can check there are three options which are correct, that is B, C and D. Next problem was related with continuity differentiability. You have two functions. One function is related with x square minus 3, since it is a box I can take minus 3 out, and x was ranging in the interval of -12 to 2. In this interval just we have to check x square matches with integer. If I square it up, I can check this is ranging in then 0 to 4, and in this interval we have, apart from 0, because at 0 this is going to be continuous, as graph of x square is evenly placed on both the sides, so we have to discard 0. All other points which is going to make x square an integer are clearly going to create a point of discontinuity, which are 1, root 2, root 3, 2, which is going to make sure that option B is correct. And as far as Gx is concerned, where we have two critical points being extra introduced, that is 7/4 and 0, the function f, where that was discontinuous apart from the boundary, are certainly going to get counted. In addition to that, we should have doubt at 0 and at 7/4. If you check at 0, you will find that this function is going to be non-differentiable, because this is going to have its effect on the overall function. But at 7/4, the function is defined as 0 in the complete interval of root 3 to 2. So that function is going to be differentiable at 7/4. So as far as non-differentiability points are concerned, we have again a set of 4 points, but with a different set of points. Instead of 2, we have 0 here. Answers are going to be for this problem as B and C. Okay, next problem is related with one paragraph where we have some information about two teams with different qualities given when one is losing, drawing, or winning the game. In the first case, you are looking at the score of one team as greater than the other team. The way that data is given, you can check this is possible provided that team won all the matches or win first match and then make a draw. Alternatively, I can have a different order. In these three cases only, you will find that the score of first team is going to be greater than the second one. The probability for this is 1/2, 1/2. Probability for this as 1/2, and for draw it's 1/6. It's going to be the same thing, so let's multiply with 2. If you simplify this matter, you will find it is 5/12, which is nothing else but the option B. And in the second problem, we have to make sure that their scores are equal. You can have this situation when you have, one team win, second one win, or other way round, or both matches end up in a draw. In the first case, you have half of winning the first match and then losing as 1/3. You'll have the same answer for this, so let me double it. And then you have making draw both the cases, that is 1/6 and 1/6. This is then simplifying to 13/36, which is nothing else but the option C in that problem. Next problem was related with conic section. There you have one ellipse given with this relation between a square, b square and e square. Clearly you can check eccentricity of that ellipse turns out to be 1/3. Hence the foci f1 with negative abscissa turns out to be -1, 0, as a is 3, and f2 as 1, 0. Treating this as a focus and vertex at origin, the parabola is then going to be y square equal to 4x. Solving this with that ellipse would give you coordinates of m and n. You can check m is this and n is symmetrically placed below x-axis. And then you have to consider orthocenter of some triangle. In triangle F1MN, one thing you can check, this point is M, this point is N. My diagram is not perfect. They are not collinear points. This is how you will have a triangle. One of the altitude is clearly this line itself. So we need to solve this altitude with some other altitude. Let me consider that altitude as solving these two equations. You can check the orthocenter is going to lie at minus 9 by 10 comma 0, which is matching with the option A in that problem as far as the first problem is concerned. In the second case, you are supposed to draw tangent to ellipse at M and N. Clearly these tangents are going to meet somewhere. That point is R. With respect to this R, you can check this MN line, which is x equal to 3 by 2, is nothing else but the chord of contact. If I take this as alpha 0, with respect to alpha 0, I can safely say that chord of contact is this, and this must match with 3 by 2. So that alpha turns out to be 6. That point R is at 6, 0. Once you know that R, the equation of tangents are known, so you can manage the equation of normal also, and hence you can then figure out the coordinate of Q. Once you know the coordinate of Q as 7 by 2 comma 0, just you have to make sure in the equation of normal y is 0, you will have this coordinate. Once you know these coordinates as well as M and N are known to you, the ratios which you are looking at, that is the area of triangle MQR, turns out to be 5 root 6 by 4 using half base height, and area of that quadrilateral MF1 and F2 turns out to be 4 root 6 by 2 after splitting it into two different triangles, and hence that ratio which you are interested in turns out to be 5 by 8, which is the option C in that